Okay, we're going to pick up this section talking about triangle congruence, and you should probably recognize these from geometry. We use these to determine whether two triangles were congruent to each other or not. Well, now that we're in trigonometry and we're solving triangles, we want to know that our answer is absolutely unique, and these two ideas go hand in hand. Side, 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 and side angle side were two that we used. Uh, these situations where we don't know, like side, 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 we don't know any angles, that does not lend itself to using the law of sines. Same thing applies to side angle side. That means that angle, we don't know its side length. So we have no pairs of angles and side lengths across from them. So these are situations that we will be using the law of cosines, which you will see coming up in the next section. Now we can use law of sines for these guys, and we have been, and that's perfectly fine. There is one unique solution, no big deal. Now that last one is the thorn in the side, if you will. Angle, side, side, if it is read backwards. And yes, read it backwards. You may not swear in geometry, you may not swear in trigonometry. Okay, it's easy to remember that this is the situation that gives us troubles. We are going to use law of sines on this, but we need to be very aware that it did not prove that two triangles were congruent. Therefore, it does not prove that we have a unique solution. That is, we may have no solutions, we may have one solution, one unique, or we could have two possible triangles, and we'll get into that here in a second. Okay, this whole thing is called the law of sines, the ambiguous case, and we'll get into it probably in the next video, but when should we be looking for something funny to be going on? Well, I just said the side-side angle situation. If you have a side, and then an angle that is not included. That was probably something I should have touched on there in the last slide, so let me go back to that. When you see SAS, that means that angle is included between the two sides. So we're talking side, an angle, and a side. On the next one, the side is included in between the two angles, so you would be doing something like this, where you have an angle, a side, and then the very next angle. So the side is stuck in between, just like you see in the acronym. Angle, angle, side means you have an angle, a next angle, and a side. And then here's the side, side angle, which we have to be very careful about. And it could be that angle, or it could be this angle. So it's very likely to come up. Okay, going back. When you see that side-side angle situation, be on guard. Now here are some guiding principles as to working with triangles and what should be happening, what you should always be looking for. The fact that the largest angle is opposite the longest side. And also the fact that the smallest angle is across from the shortest side. Whatever order you list your angles in from smallest to biggest, that should be the same order for your sides from shortest to longest. They should always correlate with each other. Always check for that when you get done solving a triangle. Another thing, there can be at most one obtuse angle or one right angle in a triangle. That is because you only have 180 degrees in a triangle. If I were to have two right angles in a triangle, I'd have 90 plus 90, and that gets me to 180, but hey, what about that third angle? You don't have a third one. So we can only have one right or one obtuse angle in a triangle. Okay, and then the last thing is that the range of the inverse sine, the output of the inverse sine, if you're using that on your calculator, it will only tell you positive sign values from the first quadrant. Now, we're only ever going to be seeing positive sign values because we're dealing with positive side lengths. Therefore, it will only tell you angles from 0 to 90 degrees. Those are all acute. Therefore, if you are looking for an angle measure that is beyond 90 degrees or equal to it, if it's obtuse, there's obtuse land over here, law of sines isn't going to do it for you. Inverse sine cannot handle obtuse angles. It will never tell you if it's obtuse. Now here's a situation where we actually have no triangle. So let's see what's happening here. Let's go back to that principle of the longest side is across from the biggest angle. Well, for sure here I see that C is 115 degrees. It's obtuse. And then I see that side C is 7. Well, then we would have side B is 12. So if I'm listing them in from shortest to longest, then these should be smaller to bigger, which would mean that angle B has to be bigger than 115 degrees. That's not possible. We can only have one obtuse angle in there. So that's it doesn't make any sense. It's not going to work out. There's no way that we are going to have a triangle here that has two obtuse angles. So no solution there. Okay, here's one that has a single unique solution. So let me label what I have here, that side A is 7, side B is 6, and angle A is 26 degrees. Well, if I start looking at my side lengths, so far I know that B is 6 and that A is 7. So B is smaller than A. And then I have the angle A is 26 degrees. That tells me that angle B must be even smaller. For sure, angle B must be acute. There's no way it could be obtuse. Otherwise, we wouldn't have a triangle. So that pretty much means if these are acute, then angle C is the only one that has the potential to be obtuse. It doesn't have to be, but it could be. That also means that our side C should be the longest. So let's get working on this with law of sines. You have the sine of 26 degrees over 7 equals the sine of angle B over 6. And of course I chose to work with the B's because I don't know anything about C yet. I cross multiply and I get that the sine of 26 times 6 is 7 times the sine of angle B. So then the sine of angle B is 6 sine 26 divided by 7. Using my inverse sine, which remember is always going to give me an acute angle, I get that B is about 22.1 degrees. And if you need to pause and check it out on your calculator, go ahead and do that. But then I've got now that B is 22.1 degrees. So that means that angle C should be pretty simple. I'm going to take 180, subtract 26, subtract 22.1, and that gives me the angle C is 131.9 degrees. And I'm simply rounding to the nearest tenth. Okay, well, now I can use that again, law of sines again, to come up with side C. And I'm going to start with this pair again because I know they're accurate, I know they're precise. using it again. So sine of 26 degrees over 7 equals the sine of 131.9 degrees over side C. And cross multiplying and solving, again, go ahead and pause if you need to, do it yourself. But here we should have that side C is 11.9. Write that up there, and then I'm going to double check. Is everything in order? It goes 6, 7, and then 11.9, so that's smallest to biggest. And then on my angle measures, 22.1, 26, and 131.9. Yep, everything makes sense. Everything is in order, so that is my one unique and single solution for that triangle.